A covalent bond is usually between a nonmetal and a nonmetal, and electrons are shared, so you don't have positives and negatives. And to designate this difference, because the bonding is quite different, it's not as strong, but it's more flexible, chemists use Greek prefixes to talk about how many atoms there are. The second atom always gets an IDE ending, but you want to use Greek prefixes. Now, Greek prefixes are mono, di, tri, tetra, penta, hexa, etc., like that and stuff. Tetra is 4, not quattro. I see that sometimes. 2 is di, not bi, which I see sometimes. So the Greek prefixes are used. So NO would be nitrogen monoxide, or monooxide is okay. Usually the double vowels are omitted, so it's just monoxide, but either way is fine. Nitrogen, mono means one oxide. You always use a Greek prefix on the second atom, but the first one, you only use it if there's more than one. So as an example of that, N2O. N2O would be dinitrogen monoxide. So here we have more than one nitrogen. We're going to need to use a Greek prefix on the first one too. But the second one always gets a Greek prefix, and the second one always is IDE. So SF6 would be sulfur hexafluoride, S2Cl2, more than one on the first one, disulfur dichloride, P2O5, diphosphorus pentaoxide. You get how this works out. So N2O4, if you want to have a name for it, there's more than one of the first one, so we need to use a Greek prefix. That would be di. There's 4 of the second one. 4 is tetra, and you want to give that last one an IDE ending. So N2O4 is dinitrogen tetraoxide. Briefly, acids are really important to chemistry because they have a lot of energy associated with them. And acids are so important that usually the H is listed first. So this is an example of hydrochloric acid, HCl. The H is listed first. Most compounds, H's aren't listed first because they're not that exciting. But with acids, oh yeah, they're exciting. Now, technically, an acid is only an acid if it's dissolved in water. And dissolved in water, you get the symbol AQ, which stands for aqueous. So notice down here, hydrochloric acid in water is HCl AQ. It's in water. Hydrogen chloride, or sometimes hydrogen monochloride, it'd be just gas. There's no water. You really need the water to make an acid an acid. We're not going to make a big deal of it yet, but this will be important to us later on. So hydroiodic acid is HI. Hydrogen iodide would be the gas version, etc., etc. Nitric acid is HNO3. That would be HNO3 in water. We'll talk more about acids in the nomenclature lab. So acids are important, but bases are too. And so bases are metal hydroxides. And if acids are yin, then bases are yang. They're kind of the opposite of each other, and they're both really important. So bases are metal hydroxides. Sodium hydroxide is the most common base, probably. Sodium is a metal. Hydroxide is a polyatomic ion. And so in water, it breaks up into Na plus and OH minus ions. This is what Drano is all about. If you ever use Drano on a hose and a sink in your house, you're using sodium hydroxide. NaOH, KOH, LiOH. Notice the thing of OH. And again, metals lead the compound there. So sodium hydroxide, potassium hydroxide, lithium hydroxide. There are some nonmetals with hydroxide. So for example, C2H5OH is ethanol, and that is not a base because C2H5 is not a metal. You have to have a metal there. Again, we'll talk more about this in the nomenclature lab, but I just wanted to throw it in here.
When the hydrated compound, copper sulfate pentahydrate, is heated, the water molecules associated with the ionic solid are driven off, leaving copper sulfate with no associated waters. This compound is called anhydrous copper sulfate.
Some ionic compounds have waters associated with them. So if you look down there at the bottom, this CuSO4.5H2O, that has 5 waters connected to the copper 2 sulfate. So this is called a hydrated compound. And hydrated compounds usually have a really nice color. And when you take the water off by like heating it, they lose their color and they become anhydrous. So if you see one of these, you just use the regular name plus Greek prefix hydrate. So as an example, this CuSO4.5H2O, you would call it copper 2 sulfate. Copper is a transition metal, so it needs a Roman numeral for the Roman numeral 2. Sulfate is always -2, copper 2 sulfate. But because it has 5 waters, you'd call it copper 2 sulfate pentahydrate. The next one would be magnesium sulfate with 7 waters. That's the Greek prefix hepta. So magnesium sulfate heptahydrate. And you could have anhydrous copper 2 sulfate, which would be copper 2 sulfate without the waters, nickel 2 chloride hexahydrate, etc., etc. So not too difficult, but if you see one of them now, you'll know what to do.